Hey everyone, in this video I wanted to look at artificial intelligence development for the non-developer. I think many of us have played with Copilots, maybe ChatGPT, the Bing Chat experiences, the Microsoft Copilots, etc. And we see that generative AI. We may have created our own Copilots with things like Copilot Studio where it's that low code. But for some of the more advanced scenarios, and you may just be curious, well, what's involved if I was to actually trying to write my own bit of code to hook into one of these generative AI models? Specifically, I'm going to look at the OpenAI GPT models. And so just a little bit of fun, how as a non-developer, you could play around and create a little application that hooks into and create your own little GPT using code. So that's the goal of this video. Now, what we're going to leverage, if I think of what I'm going to need on my machine, I'm going to use Python. I'm going to use Python because I think it's a pretty simple language. Now, I'm not a developer really today. I started off 30 years ago doing macro 32 and C and then C++. You had the MFC in there and then C#. But I've never really done much with Python. I've played around a little bit, but it's a fairly simple language. I've done Java and JavaScript. So we're going to use Python. So we're going to install Python on our machine, which is super simple. And then once we have Python, we're going to use pip. So pip is its package handler to install some other components that we're going to leverage. And we're going to walk through just these bits. If you have all this already, you can just skip forward to this. And again, Python is nice because it's an interpreted language. I don't have to go and compile it every time to get it into machine code. I can just execute my program. I can edit in any plain text editor, so it's really nice and easy to use, and it's free. So step one to get Python was actually a number of different ways. If I'm in Windows, what I could actually do, and let's jump over, I could just go to the Microsoft Store. So in the Microsoft Store, I could search for Python and then just grab the latest one. And you can see I've already clicked install. So I've got 3.12 installed on my machine. Now, the other thing you could do is if you just go to python.org downloads, well, from here, you could go and download it from all the different platforms. I'm looking at Windows, but you could go and get it for Linux, for Mac OS. There's others, there's Docker images. So just go and get Python installed on your machine. And once you've done that, what you should be able to do is if you just type Python-uppercase V, it will tell you your version, or you could do Python-lowercase version. And here we can see, yep, I have Python available to me. So we have Python installed in our environment. Now, what I want to do from here is use that preferred installer program, pip, to install a few other things. Now, if we do pip install, there's somebody completing it for me, -- upgrade pip, it'll make sure I have the latest version. And then from here, I want two packages. I want to do a pip install Azure Identity because we're going to use Entra authentication to connect to our resource. So I need to install the Azure Identity. And then once that's installed, we're going to install the OpenAI component. So this is just walking through and it's grabbing those various bits for it. So while that's carrying on, so if we look at what we are doing at this moment in time, what we're going to have over here is we've got Python. We've made sure pip is updated. And then we're installing the Azure-Identity. And then we're installing the OpenAI component. So this is just so we can authenticate just using tokens using Entra. Let me jump back over. And then I need the OpenAI components as well. So then we're just going to do exactly the same. Pip install OpenAI. So that's going to get us all of the components required to write our application. Now, because I'm going to be a little bit lazy in my application, I'm going to use the currently logged on context for my application. So the other thing we want to do is make sure you have got the Azure CLI installed. And again, we can just go and install this. And once you've got that, run an AZ space login. So it's going to authenticate as you, so I can steal that context later on. So you want to get the AZ CLI installed and do an authentication with AZ space login. And then finally, install VS Code. That's what we're going to do our development in. And within VS Code, so I'm sitting in here right now, what we would do is in this icon down here, extensions, we're just going to go ahead and search for Python. And we will install that Microsoft Python language support. So we'll get that installed. And you'll see I've installed that together. So that's really just the prerequisite bits that we're going to want to use our application. So we have all of those different components, and then that is completed. So I've got everything running now ready for my environment. Now for what we are going to do, we've got this. We went through and we got also the Azure CLI, and we did that AZ login, and we installed VS Code. So they're the bits that we need on our machine to do that. And then we added that Python extension. Now this may seem like, oh, a few hoops you're jumping through, but this is it. Your machine is now ready to do development using Python. You've got a nice graphical editor with the VS Code. I could do debugging. I've got the libraries required to do the authentication. I've got the OpenAI components, and that's really all I'm ever going to need to do. Now in our scenario, we're going to create just a text-based interaction to an OpenAI model. That's all we're going to do. Now, obviously, where is that model going to run? So there's obviously many ways that I can run different types of model. We're going to use a large language model because of the size. They're going to run in a cloud service. And we're going to use Azure AI to run the OpenAI GPT model. So if we consider the Azure service, we're going to use two interfaces. We are going to use the Azure portal just once to create a certain resource we're going to use. But most of what we're going to do, we're going to use the Azure AI Studio. Now, there is also an Azure OpenAI Studio, which is OpenAI specific, but we'll just focus on using the Azure AI Studio. And what we're going to do is we're going to use GPT-4o Omni, the latest one, because it's cheaper and it's faster than the GPT-4. What we want to do, the GPT-4o is perfect. Now, to start with, when I use Azure AI Studio, the first base component, that top level, is something called a hub. And a hub is a set of components that I want to share when I go and create projects to do specific things. So think of the hub as that collection of resources, which could be data sets, it could be connections, it could be indexes, models. I can define quotas, network security, policies, all at this hub level. And what I'm going to then want to do is have an actual deployment of our model. Now, because it's an OpenAI model, I need an OpenAI resource. So in the Azure portal, I'm going to go ahead and create an OpenAI resource. And then once I create that, I will link it as a connection to my hub. So let's look at those bits. So if we jump over, so we can close all of these down. So if I was in Azure AI Studio and I was in my home, let's just refresh this. What I see is I've currently got a project under a certain hub. But assuming you came in here completely empty, if you went to your all hubs, I could say I want to create a new hub. And when I do a new hub, all I'm going to do is specify a name, the subscription it's going to be part of, because it is going to create an Azure resource. So it lives in a resource group. It's going to live in a location. I could opt here to go and create a brand new. I'm going to do it in the portal directly just so you understand the underlying resource. But I could also go and create a new service, which will go and create it as an Azure resource. I could create a new Azure AI instance. And you can see from these, it's showing me I have existing ones already. Now, if you don't have any, that's fine. You can say, hey, go ahead and create a new one. And then it will give you a review. So you're going to go and create a new hub. What it's doing behind the scenes when I create that new Azure AI resource is if you just search, so if I'm in the Azure portal and I search for OpenAI, I'll see my OpenAI type services under Azure AI services. And it's just going to guide you through creating it. It's going to live in a resource group. You're going to pick a region, give it a name. This is a name for the OpenAI resource. And you're going to want the paid pricing tier standard S0. You could go through, and really all it's going to then do is if you want public access to it and any tags you want. So I'll just select anything here. You can just do all networks. Again, we're playing around. In other circumstances, you may want to lock this down. But for now, you can just say all networks. If you want to add tags, click next and create the resource. And so now you will have an OpenAI resource type in a certain region. If you didn't have that when you created your hub, I can always just go down here to my connections. And from connections, I can hit new connection, OpenAI service, and it will show me all of the ones if I do browse. And I can just do add connection. So it makes it super, super easy. So if you have more than one, maybe you created the one when you created the hub. Now I want some additional ones. I can just go and add the connection. I can also manually enter keys and endpoint URLs to do it that way. But now I have connections to my different Azure resources that exist in the environment. So fantastic. But I don't actually have a model yet. So what we would now do is under deployments, we're going to go and create a deployment. And this is where I would select GPT-4o, confirm. And then it's going to ask me, well, which of my connected resources do I want to create it under? I'm going to use all of the defaults. Now we have a deployment name. Notice the name is GPT-4o, the letter O. Not adding a customized content filter, latest model version. And this is how I can now create and deploy this model. So this model deployment, realize what it's doing. So I had this connection, and then I'm saying, hey, I want to do a deploy of the GPT-4o. The actual GPT-4o model is living under this resource here. So it's going to create my GPT-4o. That's the name I gave it. And that model instance will have an endpoint. There's a key that I could use for the authentication if I wanted to use that. But those are the various components. Again, I could then go and create projects under the hub as well. But at this point, what I will have is a model deployed. So I would now have an instance of this. Now I've done this already. So you can see in my environment under deployments, in my WestUS 3, I have my GPT-4o that is of type GPT-4o, the actual model. I just called it the same thing. Now, not all models are available in all regions. We can always go and check the model availability. And here, if I'm looking at the GPT-4o, which is this column here, I can check the actual regions it's available in. So East US, East US 2, and this changes over time. So you would want to go and check this, but I'm using West US 3, which is one of the regions it is available in. So all of that is basically just so that I have it available to be used. And I could even now go and select my instance. So it's called GPT-4o. It's showing me, hey, look, there's a key available. It's got various bits of information about it. And it's even saying, hey, look, you can go and play with it. So if I open it in the playground, one of the things this will now let me do is to go and try and interact with it. And just so you can see, if I do view code for a second, it shows me that endpoint. So this is the endpoint. And notice the endpoint is actually of the Azure resource. It's not specific to the model. It's the name of the resource, just like the key. So that's showing me there that actual URL to go and use it. So we have that GPT-4o. So again, if I want to be super specific, these, yes, I can use it with the name to talk to this, but they actually belong to the resource itself. So we now have a model available. So this is our own. Now, the compute behind the scenes is shared with thousands of other people. We don't have our own cluster with thousands of NVIDIA GPUs powering the thing, but it's now available for us to go and start playing around with. And that playground I showed you is a really nice way to start experimenting. So in the playground, so I actually want to notice a few things. We're not going to do any additional data, but notice there's this concept of a system message. And that system message is just set to, you are an AI assistant that helps people find information. Now there's also things like parameters. This can change things. So temperature is how creative. Is it going to maybe pick a next token that's a bit more flexible? It's not the most probable. It's going to give it some more flexibility to maybe be more creative. How many past messages? Hey, it's including 10 past messages. So that's actually pretty important as well, because that comes into memory and history. So let's start chatting. So I can just type in this box and I can say, what is the tallest mountain in the world? Now, I've not hooked it into the internet or other knowledge. So this is all based only on the knowledge it was trained on. So this is pre-trained knowledge. And if we actually go and look, if we look at the different service models, I think it's on this screen, it will actually show us some of this information. Maybe it's a different page, but the GPT-4o. Here we go. So GPT-4o was training data up till October 2023. So it doesn't know anything beyond October 2023. So just an important thing to understand. But it gave us a nice answer. Now, what is the second? I'm not telling it second what, I'm just saying what is the second. But remember the idea that, and it answers it correctly. Oh, look, it's K2. Because under those parameters, it's including the past 10 messages. So it has a history. If we look at the JSON, we'll see some interesting things here. We'll see, hey, look, there's the system role. That's that system message that guides how it behaves. Then there was what we typed in. It's just not showing what we typed in, but that's the user role. Then there's the role of the assistant and what it returned. And then we typed in something else. And then, oh, the assistant. It then typed in something else again. So there are these three roles that we're seeing that are part of that. Now, these three roles are actually very important when we start wanting to interact with this. So if we have this idea that we have the model and we're going to write our own application, there's something we're going to pass in to the model, the prompt, and then it is going to inference a completion. That's the work it's doing. So what I can really think about in these interactions is that I, as the user, I'm going to give it a prompt. So that's what I'm giving it. And then the model, well, the model is going to give me a completion. And when I think of all of these, it's all in tokens. A token may be a word, but it also may be part of a word. It may be a mathematical symbol. It's going to have components for other languages. But everything we're talking about is all in terms of tokens. And when we saw that page a second ago, it was talking about number of input tokens and number of output tokens. Because this is really, really important, because tokens lets us tell it stuff like additional information that it could use because it's only trained and only knows about certain things. You'll hear it retrieval augmented generation RAG. So when I want to give it additional data, I have to add it to my prompt. And so it's telling me, well, you can pass in up to 128,000 tokens. What it can return is 4,096 tokens. And so that input, well, that's really important because that input is going to contain, yes, the stuff I'm asking, but it may also contain other information I want to send it so it can use that as part of its inferencing and what it responds with. It may also be I'm sending it all of the past chat history so it has a memory, because the large language model itself knows nothing about our ongoing conversation. It remembers zero. This is a huge shared cluster. If I want it to know anything about the past interactions we've had, I have to tell it every single time. There is no ongoing session or native memory to it. So when I send it a prompt, I have to tell it, oh, and here's what we said on the last time and the time before that. I constantly have to tell it. So if I think about these, there are those roles involved. Now, for those roles, we saw there was the system. Now, the system, well, that's all about setting the behavior of the AI assistant. You are a helpful AI assistant. And so there's content with this. So there's the role, and then there's the content I'm giving it. So for the content, for example, for that, I say, hey, you are AI assistant. You might set rules. You might set how it wants to behave if it doesn't know something. You might say, hey, you like to give jokes. You like to use emojis. Like, this is guiding how it's going to act. That's the key point. Then we have that concept of the user. So this is what the user is asking. So then we have the user, and this is what the user, that was me typing and asking those things. And then you obviously have the assistant. Now I'm going to draw the assistant a little bit over, and you'll see why. Although really the assistant role is primarily coming this way. So that's the response it's going to give. Now, why am I drawing that will make sense when we start to think about the history in a little bit. Let's look at the pricing just for a second. If we look at pricing, we're looking at a GPT-4o model. We pay for the input and the output. So it's 0.5 cent for every 1,000 tokens. So 2,000 tokens is a penny, 1 cent. Output, so this is its inferencing, is 1.5 cents. So it's more expensive doing that inferencing, which makes sense. It's doing that work. So for every 2,000 tokens, it's 3 cents. So it would be 4 cents for 2,000 and 2,000 out. So it seems cheap. But realize if I start doing lots of conversations and lots of people doing it, that will add up quite quickly. And so that's one of the reasons we want to always think about what are we really sending in that prompt, because the input tokens and the cost. Don't send it data it doesn't need to be sent. Send it enough history so it can keep the context of the conversation, but not wasting. And then be very specific in what I want it to return to me, so it's not returning a bunch of junk I really don't need. But we saw all of these in play then when we look at the playground. So when we go back and look at the playground, let's close that down, we see, hey, there's the JSON. We can see it doing those roles and that history. All of that is working. But I want to create my own. So how do we go about creating my own little application? Well, it has this handy dandy view code button. And we're going to use this to start us off. We're going to be lazy. Now it has different languages. Could do C#, but we're going to do Python. And so what we're going to do is we're just going to copy this entire block of code. So we click the little copy to clipboard icon, and we're copying it all. And then we'll hit close. So from here, we are going to go in to VS Code. You can do file, open folder, navigate to a certain folder. I've done that already. I'm in my Scratch folder. We're going to click the little icon to create a new file. And we're going to call it, well, really whatever you want to call it. But I'm going to call it small GPT.py. So I need to end it with .py. That is the extension for a Python file. And now I've opened up my file. Now notice the icon has been set automatically. It knows it's Python. It's going to use that right extension to help us. And I'm going to paste in all of that code. Now, if we look at this, firstly, we can see well, it's using those things we already did. It's importing from the OS because it's going to bring in an environment variable. And then it's using the Azure OpenAI. Well, it's going from OpenAI. And then it's using that Azure identity we installed as well. And it wants that default Azure credential and get bearer token provider. Now, it has code in here to handle searching. We're not doing that. So the 2 lines about search, just delete them. So I'm just going to delete those away. We do need this token provider. We're going to leave that there. For the client, it has this comma at the end that's going to break it. So we want to take this comma out because there's nothing coming after it. So we're going to remove that. And now, well, it has a bunch of messages, but it has some history, which I don't want. So I'm going to delete all of it except for the one message. So I literally just have role user and content. And then it has this extra body, which I don't want either. So I'm going to take all of that extra body out. And so we are just left with this super small bit of code. Now remember, I am already authenticated. That's really the key point in this. So I did that AZ login. So let's just actually open up my terminal. So we have a window open. So if I do my AZ account show, I am authenticated as my John at saviltech.net. I'm just going to do an AZ upgrade while I'm doing this demo. But if we look at what this code has, the important thing is here. It's doing this default Azure credential. And what default Azure credential does, it's very powerful. It does a lot of cool stuff. If this was running in Azure, well, and it had a managed identity, it would use the managed identity. If there was a service principal available, it would use that. If I've authenticated with AZ, CLI, or PowerShell, it will use that. So I'm using this because I can't be bothered to handle, can't bother, it's the wrong word. I'm making a very sensible decision to, I don't want to store a key. Right? I don't want to store secrets. One other option here would absolutely be I could just use that key that we saw. It had the OpenAI, the resource key. But then I would have to store it somewhere. So what do we do? So if I think about what I'm doing right now, so I'm now going to create my program. So I called it, I don't know, whatever you want to call it. But let's say it was that my GPT or simple GPT .py. Now the important thing I have to have here, remember, is the ability to use this. So I have a variable, and one of the things I have to have in here is an endpoint. Now my endpoint is just going to point to that value. And then I also have to tell it the particular deployment name, which is GPT-4o. So then I've got, it points to that value. Then I have to prove I'm allowed to use it. So one option could be, well, I could just have a variable called key, and I put in the value. That is terrible. We never store secrets in our code directly. So where would we put it? Well, I could say the key equals, and I could go and grab the value from something like an Azure Key Vault. So I can have an Azure Key Vault. I could have a secret with the API key in it, and I could go and store it in there. I could protect this with role-based access control. So whatever this runs as, maybe it's a managed identity, maybe it's a service principal, should be a user, would have permission so it could read it. That's absolutely fine. That is a fully acceptable way of doing that. However, I'm not going to do that. I'm not going to do that in red as a really bad thing. I'm just going to say we're not doing that. What we are going to do is we're going to create an authentication. And the way we're doing that is just use the current context. So again, if this was an Azure resource, it might have a managed identity. That's the best option. Or maybe if it's not running in Azure, I could have a service principal. It shouldn't really be running as a user unless I'm really running it as an interactive application. So that's the key point. But I am going to use, hey, the current context. And so when we go and look at this for a second, let's go back to my code and what it is doing. So when we go and look at this, I am saying just get a token for my current credential. And then we're going to create a client and we're going to use that token provider for our connectivity. Now, what this does mean is whatever I'm running as, so I'm running as john@saviltech.net, it needs permission to use the resource. So if I go back and look at my service, so this is that Azure OpenAI resource. If I look at access control, what I have to make sure I have given whatever managed identity or service principal or user that is running this interactively, they must be given the Cognitive Services OpenAI user at a minimum. Like we always think least privilege, but that Cognitive Services OpenAI user role, that gives me permission to call the API and do the inferencing. And so what I have done here is for that OpenAI resource, the change I made was to give my user, whatever this process is going to run as, well, this, if I look at the identity access management, I gave that user that cognitive OpenAI user role. So they are allowed to call that endpoint, which means I don't have to store the key. I don't have to do any of those things. In terms of where I store the endpoint URL and the deployment name, in this example, we're using environment variables. So I have to, on my machine, just go and set up some environment variable that tells it those basic things. So there's some environment variables, which it then goes and feeds into those. That's how it's storing it. I could use services like Azure App Configuration, which is used to store key value pairs for centrally storing application configuration. So that would be a great option. On App Service, there's environmental settings. There's different ways to actually go and do that. But the key point is I'm not putting secrets inside my actual code. That's just like a huge, huge thing we never want to do. Okay, so if we go back to our application, which is what we're supposed to be doing, so our whole point here is our application for the endpoint, it is looking for environment variable called Azure OpenAI endpoint and chat completions deployment name. Now, we saw those values, remember, in the portal. So when we go and look at the chat playground and view code, it's showing us the endpoint. That's the endpoint. Our deployment name is just the name of the resource we created. So that was, in our case, it was a GPT-40. So that was the name that we gave it happens to also be the model in our case. So we know those values. So in my case, to define those as environment variables, which is all I need to do because it's going to try and read those. Let's just clear this for a second. I'm just going to quickly paste those in. So I've created 2 environment variables, chat completions deployment name, and Azure OpenAI endpoint. This is PowerShell window, so I can just define those environment variables that way. And notice they match the names of the environment variables it is going to try and find. So what question do we want to ask it? Well, let's stick to our mountain theme. What is the highest mountain in the world? So we've got this message, which is, it's a list of dictionaries, right? So a dictionary, we have this key name and a value name. So role is the user, the content is what is the highest mountain. So the user is asking this question. That's all we're doing in this very simple bit of code. And then what it's doing right now is when we send this to the client, we're going to store the response as completion. And then we're going to print out everything it sends us converted to JSON. So we can maybe see it a little bit easier. And so we save this. And again, we clear this. So to run it, we just type Python. And then I can just do my small GPT.py. Because it's in PowerShell, it's a dot slash in front of it. But I'll just execute that. Give ourselves a bit more room. So that is now going through. It's got that authentication. It's going to go and call the endpoint and then output using JSON format the response it gets back. So we got a response back. Now notice it's showing us the content filter statuses at the bottom, so we can see those content filter results. It shows us usage information. So this is interesting. We can see the prompt tokens was 15. So the words we typed in 1, 2, 3, 4, 5, 6, can't count, 8 words, but it was actually 15 prompt tokens. Completion tokens was 64. And then if we scroll up, we get choices. So it's going to be an array of choices. And the first one, the index 0, we got the message. The highest mountain in the world is Mount Everest, blah, 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 blah. So we can see we got that. So it worked. So this was our program. That's great. But here's a challenge. So let's change now. What is the second? And I'll save that. Let's clear the screen and run that again. So we can see it responded. So let's see if it gave us our answer. It's confused. The term second can refer to different concepts. Okay, so why has it done that? Well, it makes total sense. It has no memory. We talked about that. I have done nothing in my application to give it any memory of any kind. So when I just ask it, what is the second? I guess I'm glad it gave that answer. Being an artificial intelligence, it may have said human beings. That would be terrifying. So we have to give it some memory. Like right now, it has no concept of what came before. So that's what we want to do. We want to go and add in the ability for it to actually have some memory. So let's give it the ability to remember stuff. So all I really want to do is if we think about all of these messages, what are these messages? Well, they're really just, again, it's a dictionary. It's this concept of 2 key value pairs. So we've got role, user, content, what is the second? So what we should do is define this as our own little dictionary. So what we'll start off with is let's paste in some code. So we'll scroll up here. So we've got the endpoint, we've got the token provider, and we've got this completion. So what I want to do is create this idea of a dictionary. So it's going to be a list of our messages. And what we'll actually do is we'll populate it, first of all, with the role of the system message. And we'll set the content to be that you are an AI assistant that helps people. So we've established this. And what would also be nice is if we want this memory and these ongoing communications, we really want the idea that I can type in the question and it will keep prompting until I say stop. So what we're going to do is, after we've defined this, I'm going to paste in a little bit of code. And all we're saying is like, while true, let's just get that. So while true, get input from the user and type finish to exit. And then if it actually equals finished, then break out. Now with Python, there's no squiggly braces to do chunks of code. It's all about the indentation. That's everything it's doing. So what I actually need to do here is I want this completion to be part of actually what we're having here. So I'm going to go ahead and take this and tab it over. So it's part of this while true loop. But also what I want to say is, well, actually a number of different things going on. We've got this idea of the messages. So right now I've prompted the user to enter something that I've stored in user input. So I want to add that as the role of the user and as part of the content. Remember, we have this array. So I want to take this array, because the user has typed something useful we want. And I'm going to say the message array, well, let's append to this a new dictionary entry. And so that dictionary entry is going to be the role. So who's typing this? Well, it's the user. And then we're adding to that then the content that they actually type. Well, the content is going to be the value of user input, the thing the user typed in. So we're adding to our list of dictionaries what the user just typed in, which also means what we're sending it here, well, we don't send this anymore. We're going to send it our list of dictionaries. So all we're going to do is send it messages array. While we're playing around in here, I'm also going to add in a new line to say max tokens is 500. So this is the maximum number of tokens it can use for the completion. Now there's other things I could do here. You actually see it's prompting me. If I start like temperature, remember we saw the value for how creative do I want it to be. I could set it to some value 0.5 or whatever I want to do in here. There's other things I can do, but I could play around and do other things. So now what have we done? We've started on this concept of starting to be more flexible. Let us type things in. And then we just print out what it returns. Well, that's probably not ideal either, because I don't want all of that really kind of ugly JSON. So what we'll do is, hey, this completion is what they respond with. But if we actually want the completion message, well, that's the completion. Remember, there was the array of choices, and we want the first one, choice 0. And what we want is the message content. So now we're storing in whatever it typed. And I guess we should output that to screen still. So then we'll be nice. And from here, we'll do a, hey, print. And we'll do a little arrow so it knows it's it typing. Plus completion message. And then we'll do a new line. So that's the escape character for new line in Python. So there's a whole bunch of stuff. And obviously now we don't need to do that print line. And what we could say is, I guess at the end, if they've exited, have a great day. Nice chatting with you. So we can save that. So what have we done now? We didn't change really any of the start. We created a list of dictionaries, we set our system message. We're prompting the user to enter something until they type finished. Whatever they type in, we're adding into that list of dictionaries whatever they typed in. And then we send that for the completion. We extract the content of the message and we print it. But the other thing, well, what would be nice to maybe do? Well, actually, let's just see what that does. So we've saved it. Let's clear the screen and we'll run it again. So, what is the tallest mountain in the world? Oh, I spelled mountain wrong. Mountain in the world. Tallest mountain in the world is Mount Everest. Fantastic. Okay, what is the second? Does this work? So it works. Then we're typing finished. Have a great day, night. Now, it worked. A little bit on purpose, a little bit we got lucky. Because what did it do? So let's think about what we have facilitated at this moment in time. So remember, we created this array, this list of our dictionaries. And so we populated the system, we populated the user, and the reality of this actually is we have n number of these because we keep appending it. But actually, all we're doing right now is adding what the user types in, not what the assistant responded with. Now, it's smart enough to know that originally I said, what is the tallest mountain in the world? And it gave a response. And then when I talked to it again, I said, hey, I asked you before, what is the tallest? Now I'm asking you, what is the second? And it worked because it didn't really need to understand how it answered before. But to be the best model, it needs to know what it typed in as well. Because what we really expect to be happening here is this list, it should have the ongoing sets of responses. And we're sending that each time within a certain amount so it doesn't get too big. So the only thing really left for us to do is, because it was a little bit by accident it worked, is let's also add its response to the history as the assistant message. So let's jump back over again. And then from here, we go to the code. So what we'll do now is we need to add in how it actually responded to us. So it gave us this completion message. So what I actually want to do is I'm going to steal this same bit of code. So this messages array append that we did up here, I'm just going to copy into here as well. Make sure it's indented correctly. Now the role, remember, is not user. The role this time is assistant. And the content is the completion message. So we'll put that in for the value. And that will now give it the memory, right? So if you think about it, we set originally it just to the system message here. Every time the user types something, we add it in. And now also, whatever it responds with, we add in as well. So it has the complete audit history of every single thing we do. Now, the other thing I would like to add in is, remember, it was telling us the number of tokens. So what I'm going to do this time is let's just, right at the start, we have this messages array. Let's also initialize two variables. And we're just calling them prompt token count and completion token count, both as 0 integers. Because remember, it gave us the count for everything we did. And so if we now go and look, whatever that completion was, we took the message and then we added it. But the other thing I'm going to do before we worry about the message, well, we can say the prompt token count plus equals add to the existing value the completion dot usage. I'm using the just tab complete dot prompt tokens. And likewise, the completion token count plus equals completion dot usage dot completion tokens. And so we may as well output those at the end. And so when we're finished, we could tell them what they did. So we could say, hey, print, if I could type print prompt tokens. And rather than just type all this out, obviously I've got a cut and paste because I can't type that fast. And all we're going to do is append to it a string conversion of the prompt token count, and then completion tokens is the string of the completion token count. And if we wanted to, we could even output the history. Remember, we've just got a list of dictionaries. So in that, basically the array, I could even say, hey, your history was, and retype out everything again. So this should now give us a complete history. So let's clear the screen, run it again. Let's try something different. Who is John Saville? Let's actually be a bit more specific because I have no idea who is YouTuber John Saville. Let's see if I don't even know if this will. Let's see. Who is YouTuber John Saville? It's struggling to find this nobody. But it's been pre-trained. Okay, John Saville's a well-known YouTuber, blah, blah, blah. Okay. Is he British? So again, memory. Yes, John is British. He's known for his distinct British accent. That's fascinating. Okay. Apparently I have a very distinct British accent. I think they mean the non-posh accent, but whatever that is. But you can see now it does have the history. And to prove it's worked, remember we dumped out. If I now type finished, so have a great day, nice chatting with you. So it told us the total number of prompt and completion tokens. Now remember, I spelled tokens wrong. It makes a lot of sense that the prompt tokens was more than the completion because we included the history with the prompts. But then notice the history, it had the system, what we asked initially, its response, then what I typed in, and its response. So we have that complete based on that code we did. And I should just correct that typo in tokens. And so that was it. And to prove it was using the model, if we go back and actually go and look at our resource and look at metrics, one of the things we could do here is we could look at processed prompt tokens, and we can see it's doing these little blips. We could also add generated completion tokens, and we can see that. So we can see I'm using the model to do those various bits of work for everything we were doing right there. And hopefully it gives you a little bit of an idea. Now, this was a super, super basic program. I mean, we don't go any error checking. It's super basic. But realize we added memory to it. We added the ability to interact with it. And we created our own super, super simple one. Now, what I would really want to make sure I'm doing is start rolling off history because it's going to get bigger and bigger. Now, it doesn't allow a lot of tokens, but I'm paying for those tokens. So I still would want to improve this over time. But at a really simple level, we did all of this in our application. So if we think about what we had here, well, what we wrote was we created that messages array. And really, what that messages array was this list of dictionaries. And then we would take a user input. So this is what the user types in. And what did we do? Well, we took that and we would append it to that array. And then all we did was call the completion. And what we passed the completion, remember, was the array, and then we printed it. And obviously we did other stuff as well. We took the completion, remember, and then what we also then did was add it back and appended it there as well. So we had that full history. But that sums up what we did in our application. It really boiled down to the idea that we created an OpenAI resource. We deployed a model into that resource, the GPT-4o. We played around in the playground a little bit. We saw the parameters we could modify. We saw it had that history of a certain number of messages. It gave us the endpoint. And we saw we could have used a key, but we didn't go that route. What we did is we used the currently authenticated context. So who I was logged in as, if this was an actual application running in Azure, it should have a managed identity. I could use that. Maybe it's a service principal. If I start running against other sources of data, then I need to use delegated authentication run as the user so they can't access things they shouldn't be able to access. But I run as my currently authenticated user. Ultimately, we created a list of dictionaries which had the various roles. The system prompt to tell it how to behave, what the user asked, what the assistant responded with, but then we appended those so that each interaction, I could send it that history so it had a memory, it had a context of what it did before, and there's my application. And then I could start doing really anything else. And when you start playing with this, realize use these to help you. Hey, maybe I could even use, and I've not tried this, maybe you could use it to help me do things. So if we go back here, let's view my little terminal again. Let's clear the screen. If you're not sure how to do something, you're not a Python expert, you could ask it. How can I remove the earliest items in a Python list? Now, I've not given an example code. I could have also pasted in bits of code, but you could go and use these GPTs to help you. Go to Microsoft Copilot, for example, and go and ask these questions, and it will help guide you. And it's really good at code. If you look at GitHub Copilot, uses GPT. It doesn't have to have a special code generative AI anymore. So notice it's giving me this whole set of responses. Oh, you can use the delete statement. Okay, so delete my list 0 removes the first item. So hey, I'm stuck. I could go and ask GPT to help me with my code. I'll use the pop. Pop can remove an item by its index. So you could start playing with this and give it history and do more fun things with it. This was just really a little bit of fun. Now, the thing I do want to stress here, we did this by hand. We managed the memory ourselves just to understand the key basis of what it's really doing. In reality, if you were really developing, and we'll probably do some other videos, I probably want to use an orchestrator. Like, don't reinvent the wheel. Semantic kernel, LangChain, prompt flow, they were all solutions that do the memory part, that have templates for the system prompts, that help you hook into different models, that help you hook into different data sources. These all exist to help you along the way. But I still think it's really nice to get an understanding of what it's doing. And again, as a non-developer, how hard was that we just did to code that? There really wasn't much to it at all. We took the sample, we removed a few little bits, we created a list, we took their message and put it in, and we just got a little bit of user input, and we just added it and called their information. That was it. So as always, I hope that was useful. I hope it was a bit of fun. I hope maybe you went along with it. In the description of the video, I've got a link to the sample bit of code so you can play around with it if you don't want to type it all in. Until next video, take care.